Hello everyone, welcome back to channel. I am Ram. In the last video we have explored how to detect the outliers using z-score. In this today video we will use the more flexible technique which is IQR method. IQR is nothing interquartile range, often used with the box plot in order to detect the outliers. So before starting this video, if you are new to the channel, so guys please make sure like, comment and subscribe my channel. So now let's get started. So the first let's try to understand what is the IQR. IQR stands for interquartile range. It's the range between the first quantile, which is the Q1, and the third quartile, Q3 of the data. IQR is nothing. The IQR is interquartile range. When we are subtracting from Q1 minus Q3, it will become IQR range. The lower bound Q1 minus 1.5 multiply IQR, and with respect to upper bound Q3 plus 1.5 multiply IQR. That means this is our lower bound and this is our upper bound, right? See, if the any value, I am giving the one example with respect to the plot. Here let's try to understand what is a Q1 and what is a Q3. Now let's try to understand what is a Q1. The Q1 is nothing, this is the 25 percentile, and then the Q3 is nothing, 75 percentile. And what is the IQR? When we are subtracting from Q3, this is a Q3 and this is a Q1. When we are subtracting from Q3 minus Q1, it will become IQR, which is the interquartile range. Q1 is for 25 percentile. This center line is nothing, this is a median, and this line is nothing, this is a Q3, which is a 75 percentile, and that line is nothing, this is a maximum, and this two dot is nothing, this is the outlier. This is the upper bound and that one is the lower bound. Below this any data will be fall, it will be considered outlier. Above this any data will be fall, it will be considered outliers. Unlike the z-score, IQR, which is nothing interquartile range, does not assume the normal, which make it useful for the skewed data set, right? So now let's try to understand with help of coding. So what I did here, I have imported some basic library. The library is nothing, panda, matplotlib, and then c1. The simple data set is the value is 12, 14, 15, 13, 16, 12, 13, 600, 14, 14 and 15, right? Then I am calculating the Q1, the data, then the value, and then quantile 0.25. That means this is the Q1, and with respect to the Q3 is the quantile, the data, value, quantile 0.75. And in order to calculate the IQR, we are subtracting Q3 minus Q1. Let's try to see. So now let's try to understand. I am plotting the Q1, Q3 and interquartile range, right? So in order to plot this one, I am printing print Q1 print Q3 and print IQR. Now let's see. The Q1 value is nothing, this is the 13, and then the Q3 is nothing, this is a 15, and then the IQR is nothing, this is a 2. Now after calculating the Q1, Q3 and IQR, we can define the lower bound and upper bound, right? So in order to define the lower bound, the formula is Q1 minus 1.5 multiply IQR. Upper bound formula is nothing, Q3 plus 1.5 multiply IQR. I am again plotting this particular value so you can able to understand. Print lower bound, print upper bound. Now let's see. Now let's try to understand. This is the 18 is nothing. This is the upper bound, and the 10 is nothing. This is the lower bound. Below this 10, if the any data will be fall, it will be considered outliers. Above this 18, if any data will be fall, it will be considered outliers. Right? And then finally, we are filtering the outliers. See, data of the data value greater than equal to lower bound and data of the value less than equal to upper bound. And then we are finally printing, and let's see the output what will be. See, this is our original data, right, where the 600 is definitely outliers. This 600 is indicating this is nothing, this is an outlier. And after filtering this data, you can see we remove the outlier. Now you can see after applying the filter, we remove the outlier, because see, there is a formula, the greater than equal to lower bound and then the less than equal to upper bound. Above this any data will be fall, it will be considered outliers. Below this any data will be fall, it will be considered outliers. You can see this is the our upper bound and that one is the lower bound. Below this any data will be fall, it will be definitely considered outliers, and above this 18, if any data will be fall, it will be considered outlier. And our the Q1 is nothing, 13, Q3 is 15 and interquartile is 2. Alright, so you can see the right now this is our value after we are filtering the data. After we filter the data, we remove the outliers. You can see with help of the box, see, before removing the outlier, okay, see, right now we have an outlier. This one is nothing, this one is the, I am telling you, this is the, not working, this is nothing, this is outliers. See, as you can see, this value 600 is away outside of the box. The whisker 6, this is a 600, this is a completely, you can say this is the outliers, right? See, after filtering the data, we get the clean data with the realistical value. See, this is the outlier. Super major problem. If I cannot handle this outliers, it will be change the entire distribution because of this outlier. Because of this outlier, it will be change the entire distribution. So I hope you guys understand with respect to the outliers. Now let's try to understand when to use the IQR. Best for the non-Gaussian data, reboost the extreme value, but with respect to multivariate analysis, not great for the multivariate outliers. See, we can combine the IQR with the visual, right? You know the visual tools which is the with respect to the Boxplot. This is the Boxplot. If I can remove this 600, see, if I can remove this 600, you can see this is a Boxplot. There is no any outlier deducting. No any point is there, right? There is no any point. See, if I just talk about the upper bound outliers, so if I give the 600 is there, and then I am also giving the minus 200, okay, you can see the outliers here. This is the outlier also, this is the outlier, and that one is also outlier. So this is a powerful tools in order to visualize the outlier, and we can able to handle the outliers. Right, see, now we don't have any outliers because we remove the outliers. So that is a IQR method and the box plot for the outlier detections. In the next video we will cover how to handle the outliers, whether to remove, replace or transfer them. Subscribe if you found this video helpful. See you in the part 4. Thank you so much. Bye bye.